Right, okay. So a few years ago I was at the Scala Programming Guild at Seek, and I was talking a little bit about the challenges I'd had learning functional programming, which felt like at least it took about 100 years to do. It was probably only a few years. But I was also talking a bit about how hard it was to teach other people functional programming and some of the difficulties people seem to have. And I just finished saying, functional programming is quite hard. And this guy on the other side of the desk just sort of leaned back in his chair and with a smarmy little smile he said, "What do you mean? Functional programming's easy." I can tell you at that moment, I just wanted to launch myself across the desk and screw his scrawny little neck and scream into his face that it was actually quite hard and that people found it quite hard to learn and that maybe his experience was not typical. Or maybe he was just trying to bait me, which is more likely. I know the person and that seems like it was probably more likely. But I didn't do that. I just settled for giving him a death stare instead, because I don't think anyone's been fired for that before. But it's an interesting thing that people on average seem to find functional programming a bit of a challenge to get into, and yet for some reason they persist with it quite often for quite a while. And sometimes I wonder why this is, and I know at least in my case, it was just as simple as I thought this was going to help me become a better programmer. And I think people come at it from a lot of different perspectives, but that's a fairly common thread I find for a lot of people, is that they just want to become a better programmer, and maybe they have some sort of inkling that maybe this will help them a bit, or they think that they've experienced a little bit of it and they want to understand it more fully. So that's essentially, this talk is about learning functional programming and how people find it to be difficult. So what are some of the specific reasons? So one is that programming is hard. Don't tell me it isn't, or I'll launch myself across the desk and screw your scrawny little neck. But no, I mean, programming isn't just a natural, intuitive thing that you just pick up. Some people find it more easy than others, but it's hard, and functional programming is programming. I find this is a really common one for a lot of people. If you've already invested 20 years of your life in object-oriented programming, and you're okay at it, and you can get things done in object-oriented, and someone comes along and says, "Hey, there's this awesome thing, functional programming, you should learn it." And you start learning, and then you try to use it, and you're using it, and 4 hours later you're thinking, if I could only mutate this thing, I would have had this finished in 5 minutes. People find that a bit of a drag. They're not getting anywhere very fast, and it's just easier to fall back to the thing that you know. So this is definitely, I think, one of the bigger ones I find. Learning something new is hard. Now, I suppose I'm comparing this to the accumulation of more information. There's definitely a lot of accumulating more information is supposedly a good thing, but if learning functional programming was just about accumulating more information, all you'd have to do is go out and find some decent blog post on what a monad is, read it, you'd have accumulated the information, and you'd go, "Excellent, I know what a monad is." And the next day you'd probably do functor, discover you should have done that first, and then you might do applicative, and you go through the complete collection. And it would all just be more information. But it's not like that. People aren't doing that. They're reading their 30th tutorial on what a monad is, and they're still none the wiser, because it's not just about more information. Problematic language support. So there are obviously certain theories informing what functional programming is, and sometimes you find in certain languages that those things are not expressed very easily in the language. So at the moment, I primarily use Typescript for functional programming at work, and it would be fair to say that just sometimes the syntax of Typescript actually just gets in the way of explaining the concept, because people are there trying to, well, why is this here and why is it? And you're like, no, that doesn't matter. And then I just end up writing it in Haskell or something for them anyway, and then they look at me crazy for different reasons. I don't know, I find people who've come across this, I like the idea of functional programming, if only I could understand it, but as for functional programmers, it's a bit of a different matter. I think the most charitable way I could put this is to say that unbridled enthusiasm for a subject coupled with bagging some other topic is not a good combination on its own for teaching people a new concept. And I know quite a few people who have found that this has got in the way of them learning. It can just, like anything in life, it can just be outright taught badly. And I think this is the one I want to have a bit more of a think about. So, part of the difficulty with learning functional programming is that there's a whole lot of new concepts to learn, and sometimes to learn one you have to have learned another, and to learn that one you have to learn another. And so, jumping in and reading a tutorial about monad, I'm sorry, is not going to help you, probably. Even if you understand it, or even if you can repeat the words back, it's probably not going to be of much use to you, because there's all these other things before it that will help you appreciate why that exists. On the other hand, there's also times when there's 2 or 3 things maybe that are related, and you have to try and understand them, and they're all new things, but kind of the whole thing falls out together when you finally understand it, and you understand 2 or 3 new things. And this makes it quite a challenge to learn. Now, this is, for the sake of if anyone from Seek's, this is not production code at Seek. I haven't released any IP. It's very, very similar to some functional code at Seek. Remarkably similar, in fact, but it isn't production code. Okay, but this is probably, I would think, probably the most difficult piece of code that we have to try and explain to people on the basis of how many ideas you have to have come across to be able to understand it. So if you have a look at it, lines 1 and 2, it's defining a type. The type's a function. That's okay, you can do that in Typescript all you want, but I'll bet most people in their everyday work don't come across type functions like that very often, if ever. So it's not new, but it might be new if you've never seen it. Then there's a const pipeline that goes all the way down to line 18. This pipeline, firstly it takes parameters on line 4, where there's 3 parameters, and when you invoke it, it in turn returns a function that takes a request that when you invoke that, returns a reader task either of config error search response events. So far I've just managed to get through the signature of the function. But you need to understand currying of functions, partial function application, reader, task, either, what all of the parameters of it are. Oh, there's an IO there on line 4, like what the heck's going on there. Lines 7, 8 and 9, you've got pipe and do, like what on earth is that? This is definitely a case where Typescript syntax gets in the way of understanding a concept. You might have guessed RTE is reader task either. What's reader task either bind? What's going on here? Like bind all the way down. There's all these functions and things all over the place. Get to the bottom and suddenly map. What the heck's going on? Why are we mapping now instead of binding? What's going on there? Even if you don't know what bind is, you'd think, why is there a map there? So if you really want to understand that piece of code, you wouldn't have done that. Sorry, I was using a real operating system called Linux and it didn't work, and then I had to log into a Mac to get the presentation to work, and I had to do it on someone else's computer. Oh, thank you. Is that, yeah, all right. All right. Sorry for that break. To understand that bit of code, you have to understand do notation and why it's done with a pipe. Either task IO reader, currying partial function application, functor map, monad bind. It's not there explicitly, but it's there all over the place, immutability and pure functions. You'd have to also think, why the heck does any lunatic want to write this bit of code? You know, I've learnt Typescript, and now you've unfortunately landed on Mark's team, and here's this lunacy at work. So this is roughly the way I tend to teach people functional programming. So immutability and pure functions is almost always the first thing I run through because it doesn't require any other concepts. And here's the amazing thing, if you've got that far and you're doing that, you're doing functional programming. Or it might even be fair to say the extent to which you're doing those two things is the extent to which you're doing a functional style of programming, would maybe be another good way to put it. So the good thing is if you get that far, right, you're pretty much already doing it to some extent. Then pipe and curried functions. So, I mean, this is all because I'm doing it have to do it in Typescript with a library called FPTS. Pipe is really just function composition, but the reason I do the two of them together is if you highlight whatever form of function composition you're doing with people, when you teach them curried functions, you can then explain, well, why is it we're trying to rip all of these parameters apart and have a function that returns a function that returns a function, like instead of 3 arguments together. So those tend to go together. I'll also pretty early on talk a bit about program structure. So I don't know if anyone's tried to learn functional programming and the first thing someone says is immutability, and the first thing that pops into your head is, but what about my poor old database, right? Because I'm going to have to change something at some point. Don't worry about it. It all just works out in the wash, and 3 years later you're wondering if the wash is ever going to end, right? So usually I'll talk pretty early on about how that actually works because it's actually the question in people's minds and they really want to know about it. So I'll cover that fairly early on. All right. Then I'll do map and flat map, and in a moment I'll run through as an example what I would do with map. Then I'll do other common patterns. So these aren't your traditional type classes, but just things that people come across. For example, doing an array compact where you're getting all the options out of an array would be an example of that, a fairly common thing that people stumble up against. Again, I'll usually talk about program structure. And then the interesting thing is you can also kind of end it there for a lot of people because at that point, at least on the code base that we've got, or the ones that we've got, you would be able to get through basically everything on the code base. But if I'm going the whole way with other stuff, I'd then go into do notation, why do you need it, what problems does it solve, applicatives. I then might talk a whole lot about functor applicative monad and monoid semigroup as an alternative. But the interesting thing to note is that those incomprehensible jargon terms are right at the very end. Right? They're not at the start. You don't even need to know them. You can just get up to number 9 and you could quite happily work on the code bases that we have in production. So, how not to learn functional programming concepts. This is not a good way. In the end, functor is simply what it's defined to be, and I've actually changed it. It's usually fmap this is a bit of Haskell, by the way, but functor is basically something where you have a map function that takes an A to B, that takes an f of an A, that returns an f of a B, where the map function follows the laws that mapping the identity over is the same as applying the identity, and mapping G composed with H is the same as mapping G composed with mapping of H. That is it. Right? That is functor. You now know it. Okay? If you can memorise it, you can repeat it like a parrot, but you won't know it. And the problem I've found with this is that often people launch in with their opening thing in teaching people functional programming is something like this, like, hey, I'm going to teach you functor and this is what it is, and then they try to teach you what functor is. And the problem I've found is that the moment you put this out there for people to think about, the problem is they're thinking about it. Why? Because you just put it in their heads, and now they're going to have nightmares because of that. And every time you're talking about what functor is and trying to explain it, they're thinking about this, wondering, hang on, have I learnt this yet? And so I've found that starting with this sort of theoretical definitional learning approach, it hinders people learning. It's essentially starting with the end point of where you want to get people to, and you put it out there, and basically at that point you've half the time lost people anyway. Whereas the approach I've found that tends to work is a far more conceptual and intuitional or using analogies type of approach. And I'll do an example of what that means. But generally I try to steer away from all those jargon words. Although if you ask people that I've gone through this with, eventually you end up understanding the jargony words. So as an example, so picking out what map was from earlier on. What time does my presentation end, by the way? Is it 15:15? Yep, all right, good. So this is just a fairly standard piece of TypeScript code. So we create an array, and then we map over the array with number to string and turn every element of the array into a string. Instead of 1, 2, 3 as numbers, we end up with 1, 2, 3 as strings. So probably the only thing there that if you've never seen this before, you'd be thinking, what on earth do you want to complicate map for by doing it like it is on line 5? And the answer is I haven't got time to tell you, but for the sake of this, just understand that a.map is saying I've got an array and I'm going to map it, and the first argument is the function that you're going to be mapping with, and the second argument is the array itself. Okay, so you might draw a pretty picture of it. Usually my pretty pictures are drawn on Zoom and they look nothing at all like that, so you've got the good version of the pretty picture. Now let's just say we had an array with just one element in it. Exactly the same as before. This is basically what it would look like. Now, let's just suppose that I want to create a type that is an array that is only ever allowed to have one element in it. Because it's not an array, but it's an array that can only ever have one element in it. And guess what? I actually did. It's a very useful class for teaching purposes only and completely useless otherwise. So I'm going to create a just one. It's a different type to an array, but it is an array that can only ever have one element in it. So I make my just one, and then on line 5 you'll see I'm mapping over my array of just one element, and no surprise, I get a string with just one element, because just one enforces it. But the interesting thing to note here is line 5, that it's basically the same as on the previous slide. Okay, in fact, if you're just looking at line 5, looks very, very similar there. And that's because we're now mapping over just one, as if it was an array with just one element, which just one actually is, kind of. But here's the important thing to note. So, thinking, so what? We're not mapping over an array anymore. We're mapping over a just one. We're mapping over something that is different from an array. So if I had have said to you, talk to me about map, not map the data structure, but map the function, probably most people would just go, yeah, you use that when you want to map over an array or a list. But this isn't an array or list, it's a just one. All right, and it actually would just look the same if I drew a picture. So I've got a thing that has a value in it, and I map over it, and the value has changed, but the structure is identical. Now, if I had no elements in my array, thinking back to an array, that might be how we draw it. Now, I'm going to invent yet another type now, because I just like making types up, and we're going to call it option, and some of you already know where this is going to go. But I'm going to invent a new type option, and it's an array that can only ever have 0 or 1 elements in it. Okay? Very similar to what we did with just one, but now we're talking about some other type called option. An option, remember, that whatever the syntax is up there, just think of it as an array with just 0 or 1 elements in it. Okay, so we make up our option with 1 element in it, which is 1, and we map over it, and the result is a structure that is exactly the same as what we started with, but the value in it has been changed. Okay, and if we had an option and it was the case where it had no elements in it, it would look like this, that we make our array with no elements / option with nothing in it, and we map over it, and there are no values there to map, so we're left with nothing, but we're left with the structure. The structure is still there. So, you can imagine this looks the same with arrays or with options, that you have a value, you change it. If you don't have a value, you don't have anything to do. And you're just creating a new structure that is identical, but with the values that have been mapped. So if you think about it now, you might have started off by thinking, well, map is something I do over lists or arrays, and it's about, creating a new list or array with all of the elements in it that have changed. But we've now got 3 different types. Okay, we're collecting them. We're collecting types. We can do it with array or list. We can do it with just one, and we can do it with option. But the important thing is always that line 5. We can always map over it, and it basically means exactly the same thing. All right, so now we're going to go to yet another different type. So let's imagine you've got an option, but instead of having no elements in it, you want to have something that tells you why you have no elements in it. Okay, so an option is something that can have a value or nothing, and either is something that can have a value or something else that tells you why there is no value there. Okay, so it's basically like option with more information. So if we were to create an either, put a value into it, and right means I'm putting a value into it, it's deep and meaningful. It's because line 2, either of error or number, error numbers on the right. So that means I've got a value. Right? I can then map over it, and lo and behold, I'm left with exactly the same structure, and the value has been mapped. Okay, on the other hand, if I didn't have a value in my either, if I had an error, something telling me why I don't have a value, then by convention, the error is the left, because it's the left parameter on line 2. You map over it, there's nothing there to map. There's an error, there's something telling you why there isn't a value, so you can't map over it. So you're just left with whatever it is that you started with, which is something telling you that there was an error. And that's sort of maybe how you would draw it. The blue 1 and 1 is trying to say that's the value getting mapped. The fact that the error is in black is telling you it's not actually a value. It's something else telling you why there isn't a value that you can map. All right, another example. So far everything we've been talking about with map, you can kind of imagine as being data structures or, some form of values in the computer's memory that you're then going to do a repeat structure for. But what about task? So task isn't probably best thought of as a data structure. It's maybe a context, an execution context, a container, or something else. But you can make a task that has a number in it. And you can then map over the task, and when you do, you will turn whatever the value is inside the task into whatever the mapping function tells you to turn it into. So, lines 1 to 4, exactly the same as everything that we've done before, no different. I've got something, it's got a value in it, I map over it, I've got a new instance of the whatever it was that I started with, but the value has been mapped. Lines 6 and 7, obviously if you're teaching someone, you're getting into, well, what's the borders of the functional program and when are you doing something different, but we'll leave that now, forget about it, it's mapping that we're interested in. If you draw it, it's the same, like there is a thing, a context, a container, a context, an execution context, something that we can map over. So, how far can we push this? Is there any end to what you can do with map? Right, now, if you know what reader is, bad luck, because you're not going to understand what I'm trying to say here, because you're now thinking about reader, right? But let's say you don't know what reader is. Okay? You're actually at an advantage here if you don't know what reader is, because you can see that on line 2, reader, whatever type of thing that is, has 2 parameters, a config, and similar to either, the first parameter doesn't actually really matter for the values that we're mapping. So you can kind of think, I've got a reader with a number in it. Okay? And whatever a reader is, and who knows what it is, turns out that you can map over it, and when you do, you get a new reader, and the value that was in the reader you started with has been transformed according to the function. Right, so even if you don't know what reader is, and if you don't even try and understand what it is, because it doesn't matter. What matters is there's a thing, something else, now that you can map over to add to that big collection of wonderful things that we can map over. So, a few minutes ago, some of you would have been thinking, yeah, map, that's something I do on lists or arrays. All right, no, you can do it on lists, arrays, Mark's imaginary just one. No, it's not imaginary, I actually made it. I implemented just one, it was deep and meaningful. There's option, there's either, task, and reader, whatever that is. Now, turns out reader is basically actually just a function. And that means we're now mapping over a function, which is kind of interesting because that means so far we've covered some data structures you can map over, a thing called task, an either, which can have a value or not a value, and a value or something that tells you it doesn't have a value. And we can even map over functions. It's all just the same, means the same thing. Is there any end to what you can map over? All right, well, that's me trying to draw reader as a function. It turns out there is no end to what you can map over, because you can map over anything that takes a function A to B, that takes a functor of whatever A is and returns a functor of B, where it follows the 2 laws. And normally when I'm teaching people this, I wouldn't pull this out at this point. We just covered in a few minutes what takes me an hour or 2 hours, like a couple of sessions to go through, and I wouldn't spring this on people at the end, but you're smart-looking people, so I'm going to spring it on you now, right? That this is the end point, not the start point. Okay, having gone through what map is and how useful it is and how you can use it in all these different situations, you get right to the end, and sometimes it might be days later I tell people, oh, by the way, you learnt what functor was. And they're like, It's like, yeah, it doesn't really matter that you now know that what you learnt was functor. And maybe fill in a few gaps for them. But basically, that's pretty much the sequence that we went through. And the interesting thing to note there too is that the same as the earlier hierarchy of working through stuff, there's a bit of a hierarchy here, starting with something that nearly everybody understands, and then starting to derive other things from it, and then throwing in, like, task is similar to, future or promise, even though it actually isn't, but it's basically can be thought of as being the same. And then either, you can talk about what option was like and talk about either, and then reader, Sometimes I'll skip that, but I threw it in here because it's an interesting case to say there is a lot of things you can map over. But again, the point being that you can get through all of those things and people will understand what map is and they'll be able to use it in code. They may not even understand that what they know is functor, but you can get there eventually, and it is useful to know in the end that that's what we're talking about, but you don't necessarily have to understand it all. And for those of you who know functional programming, you can probably imagine what happens on number 7 when I do flat map, because flat map is just monad, right? But I definitely don't tell people I'm teaching them monad when I teach them monad. But I go through the exact same sequence, and you get all the way to the end, and you let them stew over the exercises for a day or two, and then you let them use it in production, and then maybe later on you tell them, oh, by the way, I taught you monad the other day. So these are just, I suppose, some of the principles that I use in trying to help people learn functional programming. Start with what people already know. Usually programmers will know enough that you can draw on that reservoir of knowledge and start building on it rather than going, oh, you've done 20 years of OO. Not many people here would have done 20 years, but I'd done 20 years of OO. And I had to go through this. No one started with what I knew, but can you tell I'm a bit bitter? Work from the simpler things to the more difficult. It's all fairly basic information, isn't it? Learn by helping people raise questions based on need. So I said people want to know, but how do I mutate something in a database early on? Show them, don't hide it, just say this is how you do it. They may not understand everything about it, but people want to know how the whole fits together in some meaningful way when they're programming and not just be told that everything's for later. Don't be afraid of intuition. I know particularly in some ways of teaching maths, there is this idea that everything should be completely abstract and that, that is how you start teaching people, and sometimes that filters into the way people teach functional programming, that it's just this abstract thing. But I've always found just start with concrete instances of things and talk about those and use those intuitions, because I think when I went through that sequence, probably most people, unless you already know all those concepts, got some part of the way through and then you kind of dropped off. And I didn't see anyone actually did drop off and go to sleep, but you probably dropped off and think, okay, I don't kind of get it anymore, right? Or you kind of go, I don't really get it, but I kind of see the map thing, or something like that. But that's the intuition you're after, to try and grab those moments of when people sort of get that glimpse of what it's about, and it doesn't have to be a pure mathematical definition, or it doesn't have to be the Haskell definition of functor for people to learn it. So, is it worth it? So, I guess when I have people for myself, I think I would say that learning functional programming is definitely worth it. Okay, I don't know how popular it is these days because I'm old and I don't look at YouTube, so I don't see most of the rants, but there used to be advice of learn a new language every year. Right, now it's probably a bit unrealistic because I know nearly 30 languages by now, but if you learn a new language in a different paradigm every so often, you will find that will give you much greater benefit than, say, if you know C# going and learning Typescript or Java or something in the same paradigm. Okay, that's just taking syntax from one thing and carrying it over to another. But if you are either doing procedural or object-oriented programming, pick up, say, a language that's primarily of a functional style, and you will learn a lot more, a lot faster. Same if you happen to know functional, you probably should pick something in a different paradigm and learn that. But it pays back. And I think in practice, I would say to most people who land on my team or who I speak to about this, I say, just learn functional programming. Like, that will make you a better developer faster than nearly anything, like at the level of actually just coding that I can think of. And I think that's largely, the evidence has largely borne that out. Now, is it worth it from a different perspective of, say, for example, I work at Seek, and I would say functional paradigm is probably not the dominant paradigm. There's a lot of people interested in it. There's little snippets of it here and there. But, you know, our code base, the theoretical one I showed you the code from earlier, you would not be able to pick up, say, your typical standard senior developer at Seek and just stick them on that and have them instantly productive. You would have to run through all those concepts and things and help them learn it. And, you know, in practice, that's at least a few weeks worth of work to get them through that. And I've found usually I can get people productive by that point. I mean, I personally believe on that project that all those benefits of more reliable code, easier to refactor, all the usual promises that people make about functional programming probably have been borne out. But there is obviously a difficulty if you're trying to build an organisation where everyone can just jump onto any old project and work on it instantly. And I've got to admit, I probably haven't really settled in my mind, you know, at what point does it become worth it? It's in that context, because at that point you're having to think about the whole organisation and what are the organisation's goals. So we have this code base. Maybe I'll come back in a couple of years and say I was moved off the team and they threw it away the next week. I don't know. Hopefully not. But I think that's probably the more difficult question which you would need to think about if you're going into all of this. So that there, the GitHub Ombre de Queso, that's the repo that I use for helping teach people functional programming. And in case you can't Google, the second one's the FPTS library that it's largely based on. So I think that's about it. Thank you.